Gauteng, Grade 10, 2023, November Paper 1. Question 1, 1.1. Determine without the use of a calculator between which two integers the square root of 112 lies. So if it's between two integers, that means that they're just numbers with no decimals, and that means that those numbers must be perfect squares. So I want to find the perfect square, that is the first perfect square that's directly below 112 and the first perfect square that's directly above 112, and those are 100 and 121. Then when I take the square root of these, I have that the square root of 112 lies between the square root of 100, which is 10, and the square root of 121, which is 11. Next, 1.2, I'm asked to simplify fully. So for this first one, 1.2.1, we have two brackets, x minus 1 plus x squared multiplied by 3 minus x. And to simplify, I'm just going to multiply each term in the first bracket by each term in the last bracket. So I'm going to start by multiplying each term in the first bracket by the first term of the second bracket, which is 3. So I'm going to have 3 times x minus 3 times 1 plus 3 times x squared. And now I'm multiplying everything in the first bracket by the second term in the second bracket, which is negative x. So I'll have x times negative x, negative 1 times negative x, and x squared times negative x. Then I'm going to collect my like terms. So I've got this term that's got an x in it, and then this one's got an x in it, so 3 plus 1 is 4x. Then I'm looking at my constants. I've got minus 3, and that's the only one I have. And then my x squares, I've got a plus 3 and I've got a minus 1, so that's plus 2. And then the last one is this minus 3x cubed. Sorry, minus x cubed. Then 1.2.2, we've got fractions with expressions of x. So because I'm being asked to simplify, I want to get everything to be one fraction. So I need to find a common denominator of these denominators, and then I can add the numerators as normal. So to get the common denominator, I can see that this one is 2 and this one's 17, and the biggest denominator is 34. And 17 and 2 are both factors of 34. So for this fraction, I can multiply it by 17 over 17. Then at the bottom, I'll get 34, and then at the top, I'll have 17 multiplying this, which gets me a common denominator like this fraction. And then for this one, I can multiply by 2 over 2, and I'll get 34 in the denominator, and then 2 times the numerator, and then I'll have a common denominator of 34 as well. So I'm going to have everything over this common 34. For the first expression, x plus 1, I have to multiply it by 17. The second expression, I'm multiplying by 2, so I had negative 2 times 1 minus x. And the last one, I don't have to multiply by anything because the denominator was already 34. And now I'm going to expand the brackets. So for the first one, I have 17x plus 17 minus 2 plus 2x plus 7 over 34. And then I add up my x's and I add up my numbers. So my x's are going to be 17x plus 2x, which is 19x. And my numbers, I have 17 minus 2, which is 15, plus 7, which is 22. And that's all over 34. And then 1.2.3, so now I've got numbers being multiplied together and they have exponents with expressions of x. And to solve this, I'm going to want to use my exponent laws, but I can only use my exponent laws where I can add the exponents between numbers that are being multiplied together if the bases are the same. So I'm going to rewrite these numbers to have the same bases, and I can see that the lowest base is 2, and I know that I can definitely write 8 in terms of base 2, and I can write 4 in terms of base 2. So instead of 4, I'm going to write 2 squared, and that is still raised to the x plus 3. And multiplied, instead of 8, I'm going to write 2 cubed, which is still raised to the 1 minus x, and then my 2 stays the same. And now that I've got exponents that are raised to other exponents, I can just multiply these. So I'm going to have 2 times x plus 3, and then for this one I'll have 3 times 1 minus x, and then this one just stays the same. So I'll have 2x plus 6 now, times 2 to the 3 minus 3x, and then this is just 2 to the x minus 9. And now that I've got all the same bases, I've got all of them in terms of base 2, I can just add all of these exponents together. So I'm just going to have 1 base 2 now, then 2x plus 6 plus these 2, so I'm going to have plus 3 minus 3x, and then plus the last 2 is going to be plus x minus 9. And now I'm just going to group my x's and my numbers. So for the x's, I have 2x minus 3x, which is minus x, and then plus x is going to be 0, so I've got no x's anymore. And then for the numbers, I have 6 plus 3, which is 9, minus 9, so I'm also going to have 0. So I'm just going to have 2 to the 0, and anything to the 0 is 1. Now 1.3 asks us to factorize. So for 1.3.1, the first thing that I notice is that I've got a common factor of x in all of these terms. So I'm going to take out that common x, and I'm left with a bracket where the first term is x squared, the second is minus 10x, and the last is just 21. Okay, then I can factorize the bracket even further because this is a quadratic expression. So I'm going to leave the x on the outside of the bracket, and my one bracket is now going to become 2 brackets. And when I factorize, I get that x minus 3 is the first bracket, and then the second bracket is x minus 7. And if you're unsure that you did that correctly, you can check yourself by doing FOIL and multiply the 2 brackets out again. So if I multiply the first, I'm going to have x times x, which is x squared. If I multiply the outer terms, I'm going to have x times negative 7, which is minus 7x. The inner ones is x times minus 3, so I have minus 3x. And then the last ones, I have minus 3 times minus 7, which is positive 21. And this simplifies to x squared minus 10x plus 21, which is exactly what I had for this bracket. And if I multiply all of the terms by x, again. So if I multiply this by x, then I'll have x cubed minus 10x squared plus 21x, which is what I had originally before I took out this x here. So I know that I factorized correctly. Then for the next part of 1.3, we have 1.3.2, which is x squared minus z squared plus x plus z. So I noticed that with the first two terms, this x squared minus z squared, that I've got the difference of two squares, because the first term is a perfect square, they're separated by a minus sign, and the second term is also a perfect square. So if these were in a bracket, like so, I'm going to have that one bracket becoming two brackets. And the first term in both of the brackets is going to be the square root of x squared, so I've got x for both of them. And then the last term in both of the brackets is going to be the square root of z squared, so I've got z for both of them. And then one of the brackets is going to have a negative sign, the other will have a positive sign. And then I'm left with the other two terms that I had from the beginning. Okay, so now I've got two terms. I've got this one and I've got this one. And I can see that both of these terms have a common factor of this bracket x plus z. So I can take out a common x plus z from both of the terms. So I take out this common bracket x plus z. And from this first term, I am left with x minus z, and from the second term, I'm just left with 1. So I'll have x minus z plus 1. Then for 1.4, we're asked to solve for x. So for 1.4.1, we're given x minus 3 times 2 minus x is equal to negative 2x. So the first thing I'm going to do is multiply out these two brackets on the left-hand side, so I can just do that by FOIL. So the first multiplied together, then the outer terms multiplied together, the inner terms multiplied together, and the last terms multiplied together. And then I'm also going to bring the negative 2x from the right-hand side to the left-hand side, and that becomes positive 2x. And then on the right-hand side, I'm left with 0. Then I'm going to gather my like terms on the left-hand side, so I've got negative x squared. 2x plus 3x is 5x plus 2x is 7x. And then I just have minus 6 is equal to 0. I'm going to multiply everything by negative 1 so that my x squared can be positive. So I'll have positive x squared, negative 7x, positive 6. And 0 times minus 1 is still 0. Then I'm going to factorize the left-hand side. So I'll have two brackets. And when I factorize, I get x minus 6 and x minus 1 is equal to 0. So if the product of these two things is equal to 0, that means that either this bracket is equal to 0 or this bracket is equal to 0. So I have x minus 6 equals 0 or x minus 1 equals 0. And then I just solve for x. So x is equal to 6 or x is equal to 1. Then 1.4.2, we have 3 to the power of 3x minus 1 is equal to 27 to the power of x minus 18. So again, like in the previous exponent questions, I want to be able to use my exponent laws to add and subtract these exponents with x in them. So I want this base 27 to be the same base as the base 3, And so instead of writing 27, I'm going to write 3 cubed. And I don't have to change the 18 because 18 doesn't have x involved or any exponents that I have to worry about. So now I want everything that's got x in it to be on one side. So I'm going to take this term, move it over to the other side, which means it becomes negative. And then on this side, I'm just left with minus 18. So I'm going to have 3 to the 3x minus 1 minus 3 to the 3x. I can just multiply the exponents, equals negative 18. And now that I have a base that's raised to an expression, I can say that that's the same as having the base raised to one of the terms multiplied by that same base being raised to the other term. So I'll have 3 to the 3x multiplied by 3 to the minus 1, and then minus 3 to the 3x stays the same. And now on the left-hand side, I can see that I've got two terms, 1, 2, and then in each of the terms, I've got a common factor of 3 raised to the 3x. So I can take out this common 3x, 3 to the 3x. And I'm left with the bracket where the first term is 3 to the minus 1, and the second term is just 1, and this is equal to minus 18. Then I'm simplifying inside the bracket, so 3 to the minus 1 is the same as 1 over 3, and then this is still minus 1. 1 over 3 minus 1 is negative 2 over 3. And now I just want to have x's on the left-hand side, so I can see that this term with the x is being multiplied by this fraction. So I'm going to divide the left-hand side and the right-hand side by this fraction minus 2 over 3. And when I divide the left-hand side, I'm just left with 3 to the 3x. And then to divide negative 18 by this fraction is the same as multiplying it by the inverse of the fraction. So now I'm going to multiply by 3 over 2. And that's equal to 27. So now I have 3 to the 3x equal to 27, and again I can write 27 in terms of base 3. So now I've got the same bases, which means that the exponents must be equal. And so x is equal to 1. 1.5, we're asked to solve for x. So I've got this inequality. So when I have an equality and I'm trying to solve for x, I'm going to treat it just like I would an equation for x. So anything that I do on either any operation that I apply in the middle, I have to do on the left-hand side and the right-hand side. So I'm going to try and isolate x in the middle. And the first thing I want to do is get rid of this fraction here where 2x minus 1 is being divided by 3. So to get rid of that divide by 3, I'm multiplying the middle bit by 3, which means that I have to multiply the left-hand side by 3, and I get negative 3. And I'm also multiplying the right-hand side by 3, and I get minus 9. So I'll have minus 9 is less than or equal to 2x minus 1. Is less than minus 3. Then I'm still trying to get x on its own here, so I'm going to add a positive 1 to the middle to get rid of this minus 1, which means I'm adding a positive 1 on the right-hand side, and I'm adding a positive 1 on the left-hand side. So I'll have minus 8 here, 2x here, and minus 2. And then finally, I'm just going to divide by 2 in the middle to get x on its own, which means I'm also dividing by 2 on the left-hand side and on the right-hand side. So I'll have minus 4, and here I will have minus 1. Then 1.6, I'm told that the sum of 3 consecutive integers is 39. Determine with the use of an equation the 3 numbers. So if I've got consecutive integers, that means that the first one is a number that I don't know, we can call it x. Then the next one is going to be x plus 1, because it's an integer and it's consecutive. And then the one after that is going to be x plus 1 plus another 1, so it's x plus 2. And I'm told that the sum of all of these is equal to 39. So my equation is going to be x plus 1 plus x plus 2 is equal to 39. I gather all my x's on the left-hand side, so I have 3x, and then my numbers are 3, 1 plus 2 is 39. Then I want x on its own on the left-hand side, so I have 3x. I minus 3 from the left-hand side, which means I also have to minus 3 from the right-hand side. And then I just divide everything by 3 to get x. So x is equal to 12. Right, so the first number was 12, the second number was 13, and the last number was 14. And you can check to make sure that you got the right thing. So 12 plus 13 is 25, and 25 plus 14 is 39. And then the last part of question 1.7, we're asked to solve simultaneously for x and k, and we're given 2 equations for x and k. I'll call this one equation 1. And this is equation 2. So I want to solve simultaneously by substitution, which means that I need to get an expression for x as x equals something with a k in it, or k equals something with an x in it, and then I'll be able to substitute either one of these that I have into one of the equations, and I'll be able to solve for one variable, and then using that answer that I find for the one variable, I can substitute that back into either one of these 2 equations and find the value for the other variable. So the first thing I want to do is find one of x or k as an expression of the other one. And the easiest way to do that is going to be with equation 1, because I can see that if I divide the whole of equation 1 by 2, I'm just left with x here. This one's going to be 2k, and this is 10. And then I can take the 2k over to the other side, it becomes negative. Then I've got an expression for x in terms of k. Right, so I'm just going to rewrite equation 1 as x plus 2k equals 10. And then I can take the 2k to the other side, it becomes negative. So now I've got an expression for x in terms of k, and I'm going to substitute that into equation 2. Then in equation 2, I'm going to end up with only k's, and then I'm going to be able to solve and get a value for k. So if I'm substituting this into equation 2, that means that everywhere that I see an x in equation 2, I'm not going to write x, but I'm going to write 10 minus 2k. So I'm subbing my expression for x, 10 minus 2k, into equation 2. So I'll have 7, 10 minus 2k plus 3k equals 19. Then I distribute the 7. Then I'll have all of my k's on the left-hand side and all of my numbers on the right-hand side. So minus 14k plus 3k is minus 11k. And then 19 and the 70 is going to become negative when I take it to the other side. So 19 minus 70 is minus 51. Okay, there's a typo in the question paper, so this isn't 7x plus 3x, it's actually 7x minus 3k equals 19. Okay, which means that when I collect my k's on the left-hand side, I'm here now, where I collect the k's on the left-hand side, I'm going to have minus 14 minus 3k, which is minus 17k. And then I just divide both sides by 17, and I get k equal to 3. So now that I've got a value for k, I'm going to substitute this value for k back into equation 2, and then I'll be able to get a value for x. So everywhere that I see k in equation 2, I'm not going to write k, I'm going to write 3. So I have 7x minus 3 times 3 is equal to 19. So I take my 9 to the other side, and I'll have 19 plus 9, which is 28, and then x is equal to 4. And similarly, you could also sub k back into equation 1. Sub k equals 3 into equation 1. So we'll just do that to check that we get the same answer. So now for equation 1, everywhere that I see k, I'm not going to write k, I'm going to write 3. I could also use this expression for k. These two are exactly the same thing. So I'm going to use the original one. So I have 2x plus 4k, and instead of k, I'm going to write 3 is equal to 20. Now I take 12 to the other side, it becomes negative, and 20 minus 12 is 8. And I have x equals 4, just like I had when I had substituted it into equation 2.